Hi, Assalamualaikum warahmatullahi wabarakatuh. So in this example, we are going to find the regression line to describe the relationship seen in example 6.3. So if you recall, we have managed to obtain the correlation coefficient of 0.8967, and that is then we proceed to hypothesis testing, and we see that there is a significant correlation between age and blood pressure. So what we did next previously was to conduct hypothesis testing, and the result is significant relationship between age and blood pressure. And now, since the relationship is significant, we are going to try and attempt to draw the regression line into the respective scatter plot. So that's what we're going to do. Yeah, so now we will be needing the same information which we have seen when you calculate the correlation coefficient. So this is the information already available from the previous example. Now what we're going to do next is we're going to calculate the value of A. So this is needed in the construction of the regression line, and you can see that from this one here, this one is the sum of yi, which is this one. So I'm going to write down this value, which is 819. So it is multiplied with the sum of x squared. So x squared is this one, so 20399 minus this one is the sum of xi, which is this one, 345, times with the sum of xy, which is this one, 634 over, now n is the sample size, which is 6, and this one is the sum of x squared, which is this one, 20399, minus this one is the sum of xi, 345, and you're going to square it, 45, and you square it, and you will get that your answer is about 81.0481. So that's the value of the intercept. Next, we're going to go on. We're going to go on and find what's the value of B. Okay, so for A, I'm just going to write it down here. This is about 81.0481. Okay, so that's the value for A. Now for B, you can see here. Well, for B, this one n is the sample size, which is 6. Next is the summation of xy, which is this one, 47634, minus sum of x, this is sum of x, which is this one, 345, sum of y, which is this one, 819, over, so at the bottom part here we have n is 6, times with the summation of x squared, so 20399, minus the sum of x and you square it, so this is x, and you square it, and so you will get that the final answer here is going to be 0.9644. Based on the values here, A and B, we are going to apply into this simple linear equation here, and so your line of best fit or your regression line is going to be y prime is equal to 81.0481 plus 0.9644x. So this is the line of best fit, and I'm sure you can insert this line into the respective scatter plot. So if you have constructed the scatter plot, this one will be at the intercept of y-axis. So roughly this is going to look like this. the line is a straight line. 81 is at the intercept, so this point is 81.0481. Okay, let me just do it properly here. So what you have is basically this is your scatter plot. These are some of the values, yeah. So now this is the intercept at y-axis, so you can imagine it looking like this, probably 81.0481. so this is the point, and we know that since this is the positive value, it is going in this direction. Now of course, if you want to know the proper value of it, you need to probably give a value to x, you get another point, and you just connect the lines, so you get a straight line. Okay, all right, I'm sure you can do it on your own. That is very simple to do. This is just constructing a straight line on the graph. Okay, right, next is, well, once the regression line is obtained, you can do the followings. For example, you can interpret the value of b. So what is the value of b? It is the magnitude of change in y when x changes exactly 1 unit. And also, once you have obtained the regression line, you can predict the value of y for any given value of x. So as an example here, what is the interpretation to the value of b that you got in the example just now? So b here is 0.9644, and so basically when you look at this definition here, it is the magnitude of change in y when x changes exactly 1 unit. So what is x in this example here? Well, my x is h. Okay, so when x changes exactly 1 unit, which means that when a person's age, for example, increases 1 year or changes to 1 year, increases 1 year to 1 year, what happens to the change in y? So what is y? Y is the blood pressure, and x here is the age. So when the person's age increases to 1 year, the blood pressure will also increase to 0.9644 unit. All right, next is some sort of example of prediction. So so here you can predict the blood pressure of a person who is 49 years old by using the equation here, which is given by this one. This is the line of best fit plus 0.9644 times x. So if you want to predict the blood pressure of a 49 years old, you're just going to substitute 49 into x. And by doing that, you will see that the blood pressure for 49 years old is going to be 128.30. So just substitute 49 into x. Now for this one here, most of the students will make a mistake of substituting 80 years old or 80 years old here into x, but you cannot do that because in this case you cannot predict the blood pressure of a person who is 80 years old, because you can only predict values that are within the range. So if you see your data set, well, if you go back to your data set here, your data set consists of the age between 43 to 70, and so the prediction has to be for values of x within this range only. You cannot go lower than that or higher than 70 years old. Okay, so for that reason, in this case here, you cannot predict the blood pressure of a person who is 80 years old, although in reality a lot of students will just go on and substitute the value of 80 into the line of best fit. So just substitute the value, and the answer that they will get is 158.20 unit, and this is wrong. Okay, you cannot do this. because the prediction has to be done within the given range of X. So X is between 43 to 70 years old. Alright, I think that's all for now. Thank you very much for watching.